Welcome. In this screencast, we take a look at everybody's favorite game, Is It Prime? We want to be able to know when we take a look at a number, at a whole number, whether or not that number is prime. Because prime numbers are the building blocks in number theory. And so if we're going to have building blocks, we have to know which numbers are prime. So let's ask, is 119 prime? Well, that's an interesting question. And which prime numbers should we check? Because we know there are lots of prime numbers. There's 2 and 3 and 5 and 7 and 11 and 13 and 17 and 19 and 23 and 27, not 27, 29 and 31 and 37. There's a bunch. How far do we have to go? Well, let's consider the following on this one. Let's ask this question. Is 120 prime? Well, no. How do we know? Well, because we can write out factor pairs for 120. There's 1 and 120. There's 2 and 60. There's 3 and 40. There's 4 and 30. There's 5 and 24. There's 6 and 20. There's also 10 and 12. So there are many, many factor pairs. Now, notice for every small factor of 120, there's a big factor of 120. So we don't need to check very big numbers because each of the very big numbers has a small number on the other side. Well, where's the tipping point? The tipping point happens at the square root of the number, because the square root of the number is the number that multiplies by itself to give us the 120. How big is the square root of 120? That's about 11. It's just shy of 11. So if we're checking primes, we only have to check primes up until that number. And if we check all the primes up until that number and we do not have a factor, then we say that our number is prime. So what's the square root of 119? It's about 11. We know that the square root of 121 is 11. So in fact, the square root of 119 is less than 11. So we check primes less than 11. Well, what are the primes less than 11? 2, 3, 5, 7. Those are the only primes less than 11. We don't have to check any others. Does 2 divide 119? No, it does not. Does 3 divide 119? Well, the digit sum is not a multiple of 3. No, 3 does not divide 119. Does 5 divide 119? That's a 9, so no. Does 7 divide 119? There's no good test for 7, so we divide. And sure enough, 7 does divide 119. And because 7 does divide 119, the answer to the question is no. 119 is not prime. Your turn. Is 223 prime? Pause the video, think about it, scribble something down. Is 223 prime? What would we have to check? We'd have to know about what the square root of 223 is. Now, I don't have my calculator handy. I know that the square root of 225 is 15, so the square root of 223 is about 15. It's a little less than 15. So we're going to check primes less than 15. Well, what are the primes that are less than 15? 2, 3, 5, 7, 11, 13. Those are the only primes less than 15. Those are the only numbers we have to check. Does 2 divide 223? No, 3 is not even. Does 3 divide 223? 2 plus 2 is 4. 4 plus 3 is 7. 7 is not a multiple of 3. No, 3 does not divide 223. Does 5 divide 223? Nope, that's not a 0 or a 5. Nope. Does 7 divide 223? That's a good question. No good test for 7. So we play this game. 7 does not go evenly into 13. There's a remainder. No, 7 does not divide 223. Does 11 divide 223? What's the alternating digit sum? 2 minus 2 is 0, plus 3 is 3. 3 is not a multiple of 11. No, 11 does not divide 223. Does 13 divide 223? Don't know. There's no good test for 13. So we try again. That's not going to be good. There's a remainder. No, 13 does not divide 223. 2, 3, 5, 7, 11, 13 are the only prime candidates less than 15. None of them divide 223. 220, oh, for the love of it all. 223 is a prime number. It is a prime number. So we have ways to check whether numbers are prime, and that is so important because they are the building blocks for us. And I hope that this is helpful to you as you process the material. See you soon.